Okay, parents, so I wanted to show you some of the ways that we've been learning division in class. I know that sometimes the new representations can be confusing at first, and they do seem a little time consuming, but I promise we will learn standard algorithms so that your child can learn a quick and efficient way to divide. But since we are introducing these concepts, it is important for them to understand the processes, and there are a few ways that will help them out. Today I wanted to talk about how to divide using an array. And as I explained before in the multiplication video, arrays are representations that show rows and columns. So for example, this representation here would be 3 rows with 4 in each row. So this is 3 times 4 equals 12. In division, this also shows that this would be 12 total dots divided into 3 rows with 4 in each row. And we did in 3rd grade cover this. In one of our units, we talked about how arrays can show you the rows and columns, and that this fact family here is part of understanding multiplication and division. But in 4th grade, we're going to start dividing larger digits, and we are going to need sometimes to understand that numbers don't always match a multiplication fact, and that there will be remainders. So what we started so far was we started with just equations like 192 divided by 4. And then when making the array, we're going to use the place value blocks, and we're going to do even distributions to help us divide. So we would begin by representing with place value blocks, a flat being 100, and then we would do the tens. So you would need 9 tens to make 90, and then the ones to be 2 ones, so 192. And then what we do is we are going to make 4 sections so that we can start evenly distributing. And this is really important because it will help the students kind of understand how this relates to the algorithm, where we are starting in the hundreds and then we just keep dividing until there aren't any more left, or until you can no longer make equal groups. So for example, right here starting, we have this 100. Well, if I wanted to put 1 in each group, I don't have enough hundreds to divvy them out equally amongst each of the 4 rows. So then this kind of helps because they're familiar with this when it comes to subtraction, which is the equivalent of division, because division is just repeated subtraction, similar to how multiplication is repeated addition. So what we would do is we take this 100, and they're familiar with the fact that 100 is 10 groups of 10. So then they would split this, how they do when they borrow in subtraction. They're familiar with like breaking it up into the next value so that they can start subtracting and borrowing. So now I have, for 192, I now have 19 tens, because I have these 10 right here that I broke from the 100 plus the 9 that I originally had. So now what I would do is I would take all of these and I start evenly distributing them amongst the 4 rows. So I can go 1, 2, 3, 4. That eliminates these. And then do it again. 1, 2, 3, 4. That gets rid of those. I still have more, so I can go again. 1, 2, 3, 4. That gets rid of those. I can do one more. 2, 3, 4. But then I noticed that I only have 3 left. So I have these 2 and this one. So I have 3 tens, which means if I were to evenly distribute them, it's not enough for everyone. So this doesn't work. So again, similar to how we do in subtraction, I would need to borrow. So I'm going to take these tens and I am going to break them up into ones. So really what we would have to do is sit and draw 30 ones, I tell the students that that would take a really, really long time. So sometimes I'll just write that this would make 30 ones. And so now I have 32 ones. This will also take me a really long time to just count them out, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20, 24, 28. And then we have that discussion about how if I do it again right now, since I broke these 30 and I had these two, I had 32 ones. So this is 28, 29, 30, 31, 32. So this actually works out really great because I can make them all evenly distributed. We're very familiar with this tic-tac-toe here where we're skip counting. So because we're dividing by 4, we would skip count by 4. And this is how we are kind of using these representations to help us make relationships between our multiplication and division. Is, for example, right here, I was distributing these 32 ones. When I list out my multiplication facts, I can see right here that 32 is 8 groups of 1. So right here, this is represented that when I did the 4, it was 1, 2, 3, 4 rows, and each row has 1, 2, 3, 4, 5, 6, 7, 8. So this represents those 4 rows of 8. So that's where I got rid of my 32. This will kind of come into play when we start with remainders, because had this actually been like 194, then for 194, instead of this ending in 32 ones, I would have ended up with 34 ones. And so since that number isn't a factor of 4, they would have to have these last 2 that don't have anywhere to go, and that's where we'll introduce the concept of a remainder. But for right now, this representation, it helps to show that when I divide every row, 192 divided by 4 is going to give me 10, 10, 10, and 10. So I end up with 40, and then I had this 8. So then the answer is 48. The reason we want to start out with these arrays is because when we move on to the standard algorithm, it matches the process that we just did. So we won't do this for very long, doing visual representations, because it is so time consuming and it isn't very foolproof, because often what we see is students will start counting like this, and then the rows start getting crooked and the dots start going sideways. So it isn't very effective as a problem-solving strategy, but it does help for students to understand what they're doing, because things like here with the with the algorithm, when you're doing the algorithm to the students, when it's the first time they're ever dividing, it doesn't make any sense. It's just a lot of random steps you're asking them to do, and that's really hard for them to recall and remember. But having built foundations with these representations, it helps out that here, this was the one group of 100, the 1. It is 100. And one group of 100 wasn't divisible by 4. So we broke it into tens. So when you take the 1 and you break it into tens, I now have 19 tens, which is what I had right here. And so when using the 19 tens, what I was able to do was start putting them in groups of 4. So 4, 8, 12, and 16. So when you look at your tic-tac-toe over here of your multiples of 4, you see that you don't have enough for 20, but you can distribute 16 evenly. So that was 1, 2, 3, 4. So that's how we explain to them that you can make 4 groups of 4, which gave away 16, and we did that here. But when doing that, we still had these 3 left over, which is the 19 minus 16 is 3. And then when we just teach algorithms, it becomes really arbitrary to just tell them to bring down the 2. But when they have this memory of physically breaking these numbers here, like we did with the breaking the leftover 3 10s, which is where we are now. We're at the 30, which is 3 10s. When you break them into ones, so you had these 2 ones plus the new 30, you now have 32 ones. So now we go in and we try to divide these 32 ones, which is what we did when we were placing all those blocks up here in the array. And then that's where we would go back here and we would match it to the multiplication fact. So if I have 32 ones, just like here, I can look and I can count 1, 2, 3, 4, 5, 6, 7, 8. So I can make 8 even sections of 4. So if I'm counting in 4 rows, by the time I distribute them into each row, by the time I'm done, there were 8 in each row. So that's why this was really important to know that 4 times 8 is 32. This is why we taught this in 3rd grade. So here, I can make 8. So 4 times 8 is 32. And when I distributed all of those out, I got left with no remaining blocks. So this is why it's really important for them to kind of understand how to do these arrays, because it's going to help them when we're doing the algorithm. We're not going to do arrays for very long. We did practice it for a couple of days last week. And we will probably use it a couple more times, and then we are going to move on to the algorithm. So I wanted to make this video in case your child is really, really struggling with memorizing the steps to the algorithm here. It can help to take a step back and just show them that you are starting in the hundreds and then you're working your way to the 10s and to the 1s until all values have been distributed as evenly as possible. And in 4th grade, just a fun fact, they may run into any numbers up to 4 digits. So we do divide into the thousands place. The standard is to be able to divide a 4-digit by a 1-digit number. So we'll never do anything divided by 11 or divided by 15. We'll always divide in numbers less than 10. So here, the highest we can go is dividing by 9. And then it will be numbers up to 1,000. Or up to, I guess, 990. 9,999. We'll never go past this. I hope this video helps. I know it's confusing, but I just didn't want you to be completely out of the loop of what we're doing. And as always, I promise, I'm going to do my very best to get your kid on track and for them to be as successful as I know they can.